Hello. Hello, guys. Welcome to the Virtual Philosophy Network Speaker Series. I'm your host and organizer of Philosophers and Gamblers, a philosophy group. I'm here to introduce you to today's speaker, Bruce Rout. Bruce has a master's in math from SFU and a degree in astrophysics from University of Alberta. He's done research for the National Research Council of Canada and the RCMP. Tonight, he's going to give us his reflection on the nature of mathematics and philosophy. The format for tonight will be as follows. So there's going to be a 30 to 40-minute lecture, followed by open discussion. Bruce, the stage is yours.
Thank you very much, Philip, and thank you all for being here. My name's Bruce. I'm mostly a mathematician. I have no academic training in philosophy. I do know some math and some philosophy of science and mathematics. I've been involved in mathematical and scientific research and have done a lot of mathematical modeling and applied math. This is with finding ways of getting analytic solutions, mostly to nonlinear differential equations. One of the things I want to talk about, like when I was growing up, we had this thing called the new math. And at the time in the 60s, the rage at the time were atomic bombs, which were all over the place. There was a Cuban Missile Crisis of '61, which I remember quite clearly. And the Cold War really came to a height when the Russians managed to put a satellite in space before the Americans did, which absolutely terrorized Eisenhower. And it was basically felt that the Russians had beaten the Americans to space because they had better mathematicians. And after some work, they believed that that was true. So they took an enormous amount of funding from the Cold War budget and threw it into the teaching of mathematics, particularly for children. And I was caught up in that. That's where the new math came in. The mathematics came to the fore at that time. So we all had to learn mathematics. We all had to learn how to make an atomic bomb. So we weren't allowed to graduate from high school. It was all, everybody had to, be able to show that they could make their own atomic bomb, which previous generations, I believe, had put this into place because they had gone through a previous war. They had watched their friends and comrades die for a particular cause, and also in the most pretty well horrific circumstances or terrifying circumstances. So I guess what they felt was we better teach all our kids how to make an atomic bomb. So if anyone nukes us, if anyone's left over, we can throw one back. The previous generation sort of had these feelings, but the interesting thing is, in spite of it all, since we all knew how to make an atomic bomb, that we as a generation rejected the mores of the previous generation. Nobody actually made an atomic bomb out of a rather large number of people who knew how to do so. And that was because we were also taught the philosophy of how to handle this particular knowledge. When the Vietnam War came up, there was a huge reaction to the Vietnam War in protest. Never want to see one of those things again. And that's that. Now, today I'm looking back and seeing what was this particular philosophy as I look at my mathematics and so forth and try to go back and take a look at that particular philosophy. So I'll start this up. So basically, I've written a book about it, just a little book to explain this. And this particular talk is a brief introduction to the ideas that I'm presenting. So just to begin, getting started, what I'm doing is I'm bringing in the world of philosophy to mathematics rather than trying to bring mathematics into the world of philosophy. And I came across this wonderful question by Jean-Paul Sartre in Being and Nothingness. All this talk by Hegel about existence is wonderful, but what in the world does it have to do with truth? That was a brilliant question. So beginning, I guess, from my own journey as a kid, I really like Socrates, who asked three particular questions. These questions are: what is truth? How can we know truth if it exists? And if we can find truth, is it worthwhile? I admired Socrates because he gave his life for truth itself. and I was really impressed with that. I thought it was great. I didn't get up much when I was a kid, but anyway. And the next question, of course, is what is the relationship between truth and existence? So I'm looking at this idea that Socrates has about truth, and then going into existence itself and what is the relationship between them. Also, a question is, of course, always, does it matter, and why bother even asking this question? Let's see, where are we? Come on, next one. We've already done this. Okay, the premise that I'm putting forward is to talk about objective reality. And there's a big movement within the science world that objective reality exists and that we can prove it with mathematics. There's a lot of leeway in what is meant by a proof. There's a mathematical proof, proof from evidence or phenomenological proof, or perhaps a rational proof to take a look at analytics or the rational proof. And there is such a thing as a mathematical proof and a physical truth. And I'm asking how they are related. And I'm also saying that our outlook on the universe makes a difference in our behavior. So we have our subjective world on what is within, okay, the self in absence of the universe around us. And in the absence of the universe around us is our subjective world, I will say. This is where we are subjectively, the perceptions that come to us and so on. The outer world or the universe that we have to deal with, the universe that is around us, I'm talking about this as our objectivity in the objective world. I think, these principles are fairly obvious. So in grade 7, 1961, they started us off with Aristotle, which is prior to the establishment of the axioms by Euclid. So 3 statements by Aristotle, which are in the category. We may categorize things. There is a difference between a category and what is being categorized, and no category may be a category of itself, or great evil will ensue. This was about 350 BC. This statement, the third statement, no category may be a category of itself, or great evil will ensue, I think is the statement in Faustus by Goethe, where Faustus is saying he hunted through Aristotle and found the key to be able to summon the devil. And I think that this is the statement here for Faustus summoning the devil. Now, Faustus was the story of a philosopher, and Goethe's, I think, either first cousin or brother or whichever, but very, very close relative was Schopenhauer. And I think that the story of Faustus very much reflects Schopenhauer. My first mathematics textbook happened to be The Elements by Euclid, and I had to pretty well memorize it in grade 4. The axioms of Euclid itself are based on the work and thinking of Aristotle. So we can get the axioms pretty well from these 3 statements here. Now, hopefully this doesn't go backwards, so I'll move on to the next slide. Thank you. So metaphysics. Okay, it says I can read from my written notes and follow along, but this won't last for very long. Anyway, metaphysics, people talk about metaphysics, and I realize I haven't got a clue about physics. Metaphysics means beyond physics. So you have to know something about physics in order to discuss metaphysics with any integrity. So physics is based on mathematics. Why? Because there are no physical laws of the universe that can predict or properly be applied to phenomena. Only mathematics can describe, to derive a solution. An example is gravity. Okay, I'll bring up as an example. There's no physical law of gravity that can predict anything. Mathematics can predict things. There are mathematical laws and actual theorems. So only mathematics itself has actually laws in which we as scientists can actually discover how the universe is actually working. So we model, the way this works, we model or create a mathematical construction to derive a physical situation. And then basically we follow the mathematical consequences. We solve the problem, if you like, of our model to reach a conclusion, commonly known as a solution. And then we try to map that solution back into the physical world. And if we're lucky, we test the result. And sometimes we're very lucky, we are able to test the result, and the results matches what we had thought would happen because of the mathematical construction. This really is the scientific method. They talk about scientific method. We have a hypothesis, and then we test the hypothesis. Not really. That's a very shallow way of looking at it. The hypothesis has to be a mathematical derivation or a mathematical construction that actually solves a problem. So we start with A, we end up with D, E, or F somewhere down the field, and then we can take that and map that back into the physical world. And if we're really, really lucky, it matches. So that's really what the scientific method is. So the first person really to get a handle on this was Galileo. Nature speaks in the language of mathematics. If you do not know her vocabulary, you will not understand a word she is saying. Of course, Galileo was the one who eventually was arrested and probably poisoned to death. He went through the Spanish Inquisition, etc. It was quite famous, etc. So this is an art form. This is an art form known as applied mathematics. The most important thing to remember about applied mathematics is that it has absolutely nothing to do with reality. The reason we're able to make predictions is an absolute miracle. We have no idea why it works. There should be some connection. We have no idea what it is. So we have this mathematical construction, we test it, it actually comes through, and isn't that nice? And then we think there may be something to the equations that we've come up with or the theories that we've come up with. So looking at gravity. Now, if we're looking at gravity, Newton described forces that are defined mathematically. F equals ma is, of course, the big one that comes to mind. So forces are defined mathematically, and there's forces between two objects that are also mathematically described. And it works very, very well if you ignore the speed of light, or the fact that Newton basically didn't know that the speed of light actually existed. He thought it might, postulated it. Galileo tried to actually measure it. It was either really fast or instantaneous. They didn't know if such a thing as the speed of light actually existed, or if it was infinite. But if you assume the speed of light is infinite, then all of Newton's laws work beautifully. They describe gravitational reactions bang on the money. So Einstein then brought in the general theory of relativity. And as described by Einstein through defining things known as length and time, and states that they have properties known as the four-dimensional Minkowski space. So a general theory of relativity is not a physical theory of the universe. It is a mathematical derivation that matches observation. I've heard all sorts of things talk about the general theory of relativity by people that haven't even read the paper in the first place. 1915 paper. It's a brilliant paper. If anyone would like to read it, go through it, pencil and paper in hand, and work out all the equations that he's come with, make sure he hasn't made a mistake. Now, shortly after the 1920s or so, it was philosophy, right? Philosophy went through a huge change in the 1890s with piano arithmetic, the invention of piano arithmetic by Peano, also known as symbolic logic. Now, philosophy could then be put into a mathematical form and then become a science. If you want to think of philosophy as a science, you can actually do that. I don't know if that is useful or not, and it's really going down to the usefulness that is important. I might talk about that later. So Russell and Whitehead, shortly afterwards, in the 20s, I believe, came up with a little book called Principia Mathematica, and it was to prove that 1 + 1 = 2 using symbolic logic. But they ran into a conundrum. The conundrum they ran into in the Principia was well known as Russell's paradox, the Incompleteness Theorem by Gödel. The two conundrums are linked, and they relate to a desire by Schopenhauer to attack and destroy Euclid's axioms. And long story short, Schopenhauer wins, destroyed Euclid's axioms, and the will dominates reality, which is where Schopenhauer wanted to go. So this is where we are in grade 7 and 8, or grade 7. Russell's paradox stems from proper sets. So R is equal to a proper set. And let's see, proper sets, R is a proper set. It does not contain itself. A proper set is a set that does not contain itself. Again, going back to the third statement of Aristotle. However, they say R is a proper set, therefore it contains itself. and is itself an improper step that gives a contradiction. So therefore, there's an improper step and there is a contradiction in all predicates. Therefore, truth as a manifestation of objective reality cannot exist. This is an incredibly brief overview. So all predicates or statements contain a fundamental contradiction, and therefore no predicate can be, quote, proven true. So Russell's paradox is written within this, piano arithmetic. If a statement A results in statement B, if A, then B. If and only if, not A, then B, which ruins or destroys predictivity, if you like, and the ability to be able to prove any sort of construction or prove any predicate, because there is this built-in contradiction, which is stated this way. So what I'm doing now is I'm going to bring up the null set. This is where we were in grade 7. The null set is the set of no elements. Now, there are other points that are brought in as axiomatic. This is not axiomatic. This is a definition. This is a useful definition, that phi equals the set of no elements. In the 21 modern axioms right now, it says that the phi is a set of no elements and is also the only set that does not contain itself. I'm going to remove that and just define phi as the set of no elements. So the next question is, does phi exist? And then the following question is, do numbers exist? This is starting both grades in 7 and 9, which was drilled into us. So we have a Venn diagram. This is the universal set, U, and within this box, this gray box, happens to be absolutely everything. So everything that exists is inside this box, and you can't go outside the box. So we now have a set within the box, which is this orange oval, and we will let this be the set S, and outside of the orange, outside of the yellow ellipse is S prime, or the complement of S. S is the set of the solutions to all problems, and S prime is the set of all things that are not solutions to problems. So S is called the solution set. So if there is no solution to a problem, we say the solution is phi, or the null set. So phi is a member of S prime, and it's a member of S. So phi exists as a member of S, and it exists also as a member of S prime. So therefore phi is a member of both sets, and it's also, because this is a universal set, it's a member of every other set. So this is a property of the null set. We know this, it's very common that this is the null set is a member of all other sets. So the set of natural numbers also contains the null set, but we just don't say it. We just don't write it down because it's basically it's not done. It's a trivial piece of information. So it's just simply understood that this is a principle of the null set. Now, I'm admitting people while we go on here, people come onto the screen, so I just keep admitting them. So with Russell's paradox, we've already had that, Bruce. Keep going, thank you. Does the null set exist? So here we are. If the null set exists, the backwards E represents if exists. If exists the null set, then there exists the null set. So obviously the null set exists, then the null set exists. This is a reflex property. However, come on, Bruce. Thank you. However, we also have that if the null set does not exist, then the null set also exists because it's a property of the null set. If there is no solution, then the solution is a null set. So the null set doesn't exist, no solution, therefore the null set exists. So basically, whether or not the null set exists, it exists. Now it's been well proven and well known the null set is accepted as existing. The null set does exist. This is just a very, very simple, if you like, overview or a little proof that I put in. So this is our interesting theorem here. If exists the null set, then the null set exists. If and only if the null set does not exist, therefore the null set must exist. So we now have this interesting theorem, which we compare, of course, to Russell's paradox. So I'm going to use this as a pen. Here we match things up. And this is now interesting that this is our little interesting theory that matches to Russell's paradox. And I'll just remove the mouse pointer. And therefore, we have found an exception to Russell's paradox. It's just a property of the null set. So the null set now brings up that we have an exception to Russell's paradox. Oh, good. I'm out of notes, so I'll wing it from here. I'm probably winging it. Now what? Okay, so what do we do now? So we now go into the definition of what a number is. And this was also drilled into us very early on. A number is the name of the set of all sets having that number of elements. Even though it looks recursive, number of elements was a matching because we have ordered sets and we're trying to find the a cardinal definition of a number rather than the ordinal definition of a number. So we have a set of ordered elements like 1, 2, 3, 4, 5. You do a matching on 1-to-1 for each thing that you happen to be counting, and therefore that's how we get the number of elements or the magnitude of the set. So a number is the name of the set of all sets having that number of elements. So example, the number 1 is the name of the set of all sets having 1 element. Number 2 is the name of the set of all sets having 2 elements. Well, there's only really one set that has no elements, and that's the null set. So the set of the null set is actually the definition of the number 0. So numbers exist because if exists the null set, then there exists the set of the null set, which is 0. So therefore 0 actually exists. And we have the number 1 exists, and now we got 2 things that exist, phi and 0. So now we got 2 things. So set 2 must there is a set that has 2 elements in it. Therefore 2 must exist, 1 exists, 3 must exist, and so forth. And merrily we go on. Numbers exist. Now what about reality? Okay, now I have to take a look at reality. Reality is a manifestation of mathematical laws. This really is, my wife and I discussed for last 35 years, or Lord knows when, about this idea of objectivity and subjectivity. And basically, and her statement was that the physics follows the mathematics. The mathematics does not follow the physics. So we start with the mathematics, and it becomes obvious. A bookshelf is a bookshelf because it follows the mathematics of being a bookshelf. We don't find a bookshelf, then find another one, say, oh, what are we doing? We have to make up a whole new set of mathematics to describe that bookshelf, which we may call something else. But no, it's a bookshelf because it follows the mathematics of being a bookshelf. The mathematics determine what actually is. So we have 3 particular laws I'm going to bring up. These 3 sets of differential equations describe all of the physical universe and physical realities, which are Maxwell's equations that describe electricity and magnetism, or electromagnetism, from the world of the very small to the infinite. Einstein field equations describe world gravitation, and also have included Maxwell's equations through the Faraday tensors, which exist within the Einstein field equations that describe the world of the very small to the infinite, and Schrodinger's equation, which describes the world of the very small to the infinitesimal. These 3 equations basically describe all of physical reality according to the world of physics. This means there is order in the universe. This is another rather interesting topic. We talk about order in the universe. Why a cherry tree is a cherry tree? Because it follows the order of being a cherry tree, or the mathematics of being a cherry tree. So we have within atoms and within subatomic particles and muons, gluons, and quarks and various other things, no matter where we look and how small things happen to be as we go on in our mathematical, in our physics discoveries, we will find order everywhere we look. There is order in the world around us. A blade of grass is a blade of grass because it follows the order of being a blade of grass, even though 2 cherry trees may look entirely differently. They are cherry trees because they follow the order of being a cherry tree. Same thing, there is order in our solar system, order in our environment, order in the structure of the galaxy, order in galactic clusters, order superclusters, and so on. Worlds within worlds, no matter where we look in the universe, we always find order. Nothing is what we would call chaotic or random. There is chaos, but there is nothing that is actually random. As a matter of fact, if you do any research into computer science, one of the first things you need to find out, oh, we need a random number generator. It doesn't take long to figure out. You can't make one. It's absolutely impossible unless you have human input. So random number generators are usually seeded or begun by the time, it takes a timestamp or when you hit the key, or when the particular random number generator was called. So there's order in the universe. Reality is a manifestation of truth, or what I go into is talking about validation. It's a manifestation of the potential to be validated. Then what about something like goodness? We see goodness around, and is there such a thing as goodness? Which is the next question. So if reality is a manifestation of truth, then what about goodness? And is there such a thing as goodness? So we come to the stone question here, what I call the stone question. Does a stone exist? Does a stone exist because you perceive it, or does your perception of the stone exist because you're looking at a stone? This, both Aristotle and Schopenhauer came up with the same answers. They said, no, if you take the stone away, your perception of the stone ceases. But if you go away, the stone itself remains there. And so it's next step we go to, okay, this is a difference between the reality and your perception. Is it possible to tell a lie because there is no truth about which you are lying? So in other words, is it possible to tell a truth with no one lying about it? So it's absolutely impossible to tell a lie if there is no truth about which you are lying. However, it's quite possible that you could be telling the truth and no one happens to be lying about it. For example, does a stone exist? Everyone say, yeah, a stone exists. Then some people will say, well, no, it doesn't, and make up all sorts of other things. Maybe that is a lie, etc. And but nevertheless, it is possible to tell the truth and no one lying about it, but it's absolutely impossible to tell a lie if there is no truth that exists. We then go into correctness and incorrectness. It's impossible to do something that's incorrect if there is no correctness about which you are being incorrect. Is it possible to do something correct and there is no incorrectness? That is actually possible. And then going into other things, can evil exist without goodness, or can goodness exist without evil? So goodness can exist without there being any evil in the world. But if there is something evil, there has to be something good in order to make the evil actually exist, if you like, or us to perceive it as evil. So I continue on and write about the coordinate system of the universe, looking at something called potential. And there is a response to Copenhagen interpretation. There is order in the universe instead of probability being the driving force of the universe. We can look at potential as the driving force of the universe. Is there potential for goodness and justice as a property of the universe? If they actually exist, they're around, they have to come from somewhere. So is that actually a property of the universe itself, that there is such a thing as goodness and justice, which is then manifested, or this potential actually manifests itself? So the space-time continuum exists, and it has certain properties. Some of these properties are path independent, which are known as conservative, and some are path dependent and therefore are not conserved. Truth is that which exists independently of our perception, which is the conclusion that we come to. And I've come to the conclusion of this talk. And I'd like to say thank you very much for being with me while this is going on. I'll now return us to stop the share. And we are now back, and I will now close this one. Escape. Okay, thank you very much. I'm going to now be open for questions. I would like sort of a hands up. That's what Philip had been saying from where I'm at. Philip, do you have anything to say? Hello, Philip, are you there? Have I been on mute this whole time?
No.
Thank you, Cole.
Yeah.
Philip went away. How you doing?
If he doesn't have anything to say, I do.
Oh, wonderful.
Yeah, I'm really interested in the topic. And I was interested to hear about Russell's paradox. I haven't actually come across that one, but have you come across anything with Alfred Korzybski and Science and Sanity? He said basically that Aristotelian predicate logic is no longer suited for the type of kind of the flux or the difference in and the law of the excluded middle being insufficient in describing reality. Have you heard of stuff like that?
Yeah, I very definitely have. It's what I've been going through. That's where the incompleteness theorem comes up from Gödel. Sometimes I refer to that as the Romanian Paradox. You can't prove a system inside the system. You can't use the system to prove itself. Okay, you need a bigger system. So you got to get outside of that system to get that one. Then how do you prove that one? So you got to go outside that system. So you have to keep getting an infinite number of systems. So in a result, you can't actually, quote, prove that particular system. Okay, so there's that problem. Now, you can reply to that with Green's theorem, meaning boundary conditions, so other things like that can describe a consistent theorem within itself. I think personally we get into a lot of trouble when we try and figure out if something is correct or incorrect. What is the real definition of something, for example? And this was right back in grade 4. We were told it doesn't matter what your definition is. You can define something any way you like, but is the definition actually useful? And definitions are kind of a precursor to truth. They're beyond truth itself. And then when we construct something, we construct a truth out of it. So very definitely, I know your concept. I know what you are talking about. And this was about 1920s, which is where Russell and Whitehead ran into this terrible problem, because it meant all the theorems that had been built up of the past 3,000 years were completely useless now, because we couldn't prove that anything was true. And that's why I've taken a relook at Russell's paradox. And this is very brief, by the way. I've gone over it. I've really skimmed over it. But there is an exception to Russell's paradox. And then going right back to Aristotle's ideas, we can categorize things, etc., that we can actually start to construct ideas and definitions of the axioms themselves and rebuild the axioms. And that it depends how you want to define what is true. You know, is it something that's consistent? Are there mathematical constructions that have stood the test of time, et cetera, that gives us some predictability? But very definitely, I know exactly what you're talking about. Yeah, I take that very much into heart, and that's what I'm looking at with this particular book.
Yeah, so what I've heard a lot about is, well, I've recently been reading about, is that when you define a logic, you basically are defining a set of axioms that you have to go by, or as you just put it, definitions. So just basically that you have to define something that's kind of outside of the logic in order to prove what's inside the system, kind of like to go along with your language. Yeah, I myself have been looking upon, like, in terms of, like, say, if you want to define if killing someone is bad, you know what I mean? You could use certain types of logic, like, well, say you value something like thinking. Well, if you value thinking, then killing another person is bad because that's more thought, that's more of a, a contribution to the thinking community, is if you don't kill somebody. So, but then again, you're assuming something. And I was just thinking, I wanted to translate the goodness aspect into an objective, or translate morality into an objective logic. But what you're saying is that the logic basically can't prove anything.
In a way, yeah, I think we're sort of getting into a quasi postmodernistic dilemma, where you have your truth, I have my truth, okay, and we'll just let it happen. If you live in simply a subjective world, so that I have my subjectivity, so I don't have to relate to the universe around me. So you're part of the universe around me, and I'm part of the universe around you. Because we now have to react between each other in our relationship with each other, there's going to grow out of that, from experience, a set of, let's call them, rules of behavior. Okay.
Yeah.
And that's now where we get into the objectivity. If I don't have to worry about the world around me, I don't have to worry about objective truth at all. But if all of a sudden I live in a world and there are people around me, and let's say there's a global pandemic that's happening, okay, now objective reality starts to become very important. And it's this postmodernistic view that there's no such thing as truth that I am very much against. I say, no, in order to have a cohesive society, in order for us to be able to live, of course there is a objective reality. Things do actually exist. Reality does actually exist. And this reality exists with mathematical laws describing it. So I don't know, does that answer your question? So no, there are predicates that we can actually prove and find results to. And they are consistent and they work. I sort of lost you, sorry.
No, you're right on track. So what I was looking at basically, so that's an interesting take because objectivism has been linked to the way you say it is kind of like social inclusion adds elements of objectivity, whereas objectivity in the past has been equated with kind of like a rational self-interest or like
Yes. Yep.
uber capitalist kind of negation of the sort of negation of the concerns of the other is how it has usually. That's just from Ayn Rand's philosophy, if you're familiar with it.
Oh yeah, I'm fully in agreement with you. Yeah, I'm fully on track with you. Fully agree.
Yeah, and I'm interested in objectivism now being a form of social inclusion, or as adding more elements to the set of people that you have more rules to go by, and basically you have overlap, or what have you. You have the set of rules generated by the set of people, yada yada.
Yeah.
But myself, I think that there is a sort of a validity to the predicate logics, and I think that I put a lot of stock in them. I've basically translated some of what Korzybski talked about, which he was a colleague of Russell and Whitehead. And he said that the word is, or to be, from the English language can't be trusted because it infers more than, or it predicts more than it actually sort of has as material. So basically, if you say he is an idiot, it's often never justified. It's just a statement that's made kind of to make baseless claims for people, who don't have a lot of proof behind what they're saying. But I've went beyond it. Say isn't. I don't argue against the word is, but it has a few different ways of meaning, like say identity. So if you say X is Y, where Y is a name representing X, you know what I mean? You don't say, if you don't say if my name's Cole, or if I say I am Cole, I'm not saying my name is the word Cole. I'm saying I am this person called Cole, Another way that is used is class membership, which is if you say sorry, going back. If you say I am human, you're basically saying that I belong to the set of human beings.
You classify yourself as a human being. Yes.
Yes. There's class. That's class membership. The other one is class inclusion, which is to say humans are animals. So you're saying basically a set is a subset of another set.
Yes.
Then you have the auxiliary form of is, which is saying I'm right. Something like that. I basically took this to mean sort of like the derivative of work over time, over a certain task, was like basically a non-zero, matrix of partial derivatives, whatever.
Excuse me.
Okay.
Maybe other. I guess Can we open the discussion to more people? Is there anyone? If you guys have have a question, you can raise your hand. Is this the end of the lecture now, Bruce?
Yes. Yes.
Okay. Anyone
I'm noticing
has a question,
PM
please
was.
raise your hand. So Joshua raised his hand. So Joshua, do you have?
I didn't see Joshua. I'm terribly sorry.
No, it's okay. I'm just curious that what we do know about human cognition, just at least, is that it's really organized around a certain effective way of organization as us being social things. So because human beings are social, a lot of our actual cognitive hardware is to understand social dynamics and interactions. And we tend to assume that our minds are there interpreting things as one-to-one from an impressionistic like material landscape of experience. But when you look at human beings from a broad like anthropological or culturally historical lens, it seems that language and much of our interaction is there as a solution to mitigate us having to deal with the immediacy of the environment or reality. Because if we look at ourselves as things in the world, we're not even the most particularly robust or strongest living things or fastest ones. We have an advantage of having the ability to abstract and to use fantasy and imitation to a very large degree to an advantage that has lifted us to a certain place in the world. But because a lot of this is something of our makeup as a social thing, can we really know with a certain amount of certainty that what we think as the fundamental basis of reality doesn't come down to a I guess like need for us to be able to organize and collude as social things, that our tendency to do this with the world itself is something that we've adapted from this social linguistic fictitious imitative nature, because even the oldest thing we see from established recorded history is a tendency for human beings to invent story and narrative and organize themselves around story and narrative before we had ideas or words like truth.
Oh, okay. There's, I'm not presenting something that's from an absolute type of situation. There may be such a thing as absolute truth or objective reality out there somewhere, but all we have are our own perceptions of it. And in order, we can go terribly wrong, and terrible things have happened if we take a set of rules to the nth degree and make them some sort of absolute rule to how we behave. We interact with each other. We're still learning. The only knowledge we can have is knowledge of our own ignorance. And the mathematics that we have is as best that we've got so far. It works very well, so we use that. But then we can alter definitions and get in a totally different view from what we're looking at, and a totally different approach, which, you know, as I'm saying, usefulness is, I think, something where we have to bring in this human, undefined type of human element to it. I think Cole, thank you very much, Joshua. Well, Cole has their hand up. And you are muted, Cole.
Sorry about that. Really interested in what the last person had to say, but also the idea of, like, say, you know, in terms of mathematics being like a meta language to sort of describe our, you know, like sentences, like I was just saying, that math can be used to translate sentences, and that the predicate logic can be used to make a conclusive decision on truth or untruth. And I have come across a few situations where, say, the direct implication is false, but the contrapositive is true. I don't know if you've sort of seen anything like that, which is basically defining to me that that it's not a complete implication that the set that is in the predicate is not the exclusive set, or there isn't just two sets that the predicate should be basically derived from. I don't know.
I know, I understand what you're saying, but then when we bring in the null set as being a subset of all sets, it describes falseness as well as truth. You know, it describes the inclusion as well as the exclusion as well. It's just a property of the null set, which now brings in an exception to just about everything. So now we have to kind of start over again, but it's not like a going back. It's not like a going back to some sort of idea where there's an absolute way of directing our behavior. All right, we have to take it kind of as it comes. I think, you know, I'm understanding where you're talking about, but like, I'm looking at mathematics as a form of reality. That mathematics itself is real, and that has described the universe. Now, we may not know what these mathematical laws are. We're still discovering them, but they're there. Okay, there is a determinism, as Einstein said. There was a determinism to these things. Now, when we get into something incredibly complex, like our behavior, that's when all sorts of different things come in, and it has to come from a set of principles. What are our principles? What do we think that is right? You were talking about, do we value thinking, for example, or what do we actually value? You know, what is there that we deem as just? And pretty well every human being understands what an injustice is, and so forth, and can kind of recognize justice. Because really, it's with the rise of I think Schopenhauer and how Nietzsche was misinterpreted, and the rise of Nazism and so forth, some pretty horrific things came out on how to manipulate human beings. I'm thinking of Hannah Arendt, for example, in Eichmann in Jerusalem, which is a brilliant book, highly recommend it to everyone, where we see the manipulation of value and other things like that caused people to do the most horrific things. You know, people who ordinarily would have been nice people just to do just unbelievable things. So yeah, I think there's a great big red flag coming up if we try and deal with certain absolute ways of behavior and things like that. So I think there's an actual danger to making philosophy a mathematics, or making philosophy a science. It's beyond that. It's different than that, because it deals with human beings. You know, just to comment on what you were saying. Joshua, your hand is up. I wanted to get back to you, Joshua, because, you know, some of the stuff you got was quite brilliant.
Well, thank you. I would agree that I think like the interest in making philosophy something of a member of science is wrong, because it is trying to deal with human beings. But understanding science as something that is a product of culture as well is something that I'm curious about, because it is the fact that human beings are involved in the enterprise of the production of knowledge that makes understanding epistemology, or our interest in truth itself, a difficult thing for me to really try and grasp as an objective thing, because as you're saying, the aspect of effectiveness is what we can use to understand, well, how close do we approximate what we really think we know or experience. But when it gets down to what we know to experience, a lot of what our thinking is predicated on are aspects of language and culture. And because we are nested in these things, where are we finding that we can pull away from language and culture to understand something as an objective lens to what constitutes effectivity and how we understand it? Because an Inuit may think of effective truth different than, say, we think of what constitutes as effectivity. I like math. I'm a math major myself, and I like math because I say math is a place where we understand that we need a category called something, because we we're really working with things where it's like what we can know is it's something, but when we're putting names to something, how is it that our naming of the somethings we can be judicious or fair in the sense that we're capturing something that is really more than what we try to understand in our normal sense of interaction and being effective social or cultural things.
Yeah, your idea of language and culture and so forth, I think is vital. I'd like to talk about that. So I've also got because it brings in a question that we just had, which is in the chat. How do we reconcile the various religious philosophy, maths, truths, etc.? If we start to bring in something like goodness, something like being right or correct and so forth, we do bring in. I think there's a spiritual attribute to it that has to be taken into consideration. And if we're dealing with, let's say, a white Anglo-Saxon Protestant way of looking at things, that will determine things a certain way. And then if we looked at something completely different, there's a totally different way of looking at things. I spent some time, I spent about 6 years with the Blackfoot, and about 2 years teaching high school in the Blackfoot. Learned enormous number of things because there, for example, what I learned from that culture was to take a look at life without having a distinction between the humanities and the sciences. The humanities and sciences are really the same thing. And that what we're looking for is reality. And this idea of goodness is really what is real, okay? And it's the reality that we're trying to become real people. And by becoming real people, it is living according to what we in the West would call like moral attributes, and by living a moral life and so forth, by always telling the truth and kindness to others and other things like that, that is becoming real, which is a culturally different way of looking at things. Maoridom and within Maori people has totally where you're carrying the honor of your ancestors and other things like that. From what, not that I'm any expert on these cultures, but that this is what I have learned from these cultures. So it gives you an entirely different viewpoint of what you're looking at. But the mathematics is still there, but you may interpret, the results of that mathematics, you may interpret the results totally differently in going to it. Or you may come up with totally different ideas in a whole new mathematics and how we can construct things. And we find that the Western way of looking at things is just inadequate. So the question is, in reconciling things like various religious philosophy, mathematical truth and stuff, if we're looking at religion, then we're starting to bring God into the picture, and God is undefined. So like it's kind of beyond, outside of our discussion. We talk about things like goodness, and that's, I think, where we should go. I think there's been all sorts of things on trying to prove God exists and stuff like that without actually having a definition of what God is. Do you know what I mean? So again, this comes into this idea of language, which is very cultural, and the idea of religion. Well, how many different religious views do we have? Philosophy is quite open to looking at many different religious views and stuff like that to see where it takes it. And yeah, I think that there is a reconciliation with it. I think it is possible for people to talk to each other, listen to other people and so forth, and being in tune with learning of completely different ways of looking at things. You're not willing to learn other people. You think you know the truth. You probably don't. So a lot of it is, is this idea of search and the idea of trying to learn, which I think is at the core of it. Okay. Thanks, Josh. Okay, Cole, back to you, sir.
Hey,
I don't see anyone else's hands are up, but we'll try to get to people and give you the time that you wish to say what you wish to say.
Yeah, so I was wondering if there was a problematic nature in saying that we're sort of limited to our own semantic or linguistic responses, and that really we don't have any we don't have any claim to objectivity in a sense that basically what they're saying is there is no true statement. So that basically a human can make no true statement it shouldn't be asserted as an objective fact while they're claiming that everything is limited and that there is no true statement except for this statement. Is there an inherent self-contradictory nature to saying there are no true statements except for the one I'm saying?
Sorry, that doesn't count. Sorry. No, if you're saying there's no true statements, you got to include the statement you just made. Sorry.
Yeah.
You can create a philosophy and a mathematics by saying, okay, we define it this way, except for this thing, okay, that is a real bugbear that destroys my whole argument. Yeah, sure, you can go, but how useful is it? Where do you go with it? And maybe it's good sometimes to take a look at that. Okay, maybe it's time. It's okay, to postulate those things, but it's a postulate. How do we build? We have to use what we call the test of time, if you like. That is things that have stood the test of time that we know just happen to work. Does that make sense what I'm saying? I think that I'm trying to play with what you've said. We can come up with a truth, 1 = 1, okay? So we have that. It's a very useful truth. And we could say, well, there is no such thing as equal, and 1 is really equal to something plus, a little bit, and, might kind of not be equal and stuff. Sure, that's possible. But it may not be very useful. You started there as a definition. It's not going to be very useful in the end. But we're saying that 1 = 1 is a very, very useful thing. And we can use that. We can define equality, for example, as being able to be replaced. That's in the world of etymology, where you're getting symbols. A classic, an absolute classic in the world of science right now is dark matter. Okay? Everyone talking about dark matter, looking all over the place for dark matter. It's not defined. There's no scientific definition of dark matter that is self-consistent, non-circular, and does not use the words as like. What are its properties? Therefore, can we determine and make predictions over what would happen, make experiments, and be able to find the properties of this thing? And so we can make another symbol. Let's call it an MFD field, for example. So we have something called an MFD field. And we're saying, well, we can't explain how this galaxy works. So it's because of dark matter. Oh, well, let's just replace that symbol with something called an MFD field. So it's not dark matter, it's because of the MFD field. So the MFD field is actually preventing us from we don't quite understand an MFD field. So, but we're looking for it. We're trying to find the properties of an MFD field, or we see this type of, things in the background, radiation, all those things that say that this MFD field has to be around somewhere, and we're trying to find it. Until we find out that MFD field just really stands for magic fairy dust. And there's no dark matter at all. It's all being caused by magic fairy dust. It makes absolutely no difference with what anyone has said if we use magic fairy dust instead of dark matter. They're completely interchangeable.
Okay? Isn't the idea of dark matter just based upon the fact that they estimate that the universe is composed of a certain amount of matter, and they don't observe that matter? Is that correct?
Yeah, what it is it comes from, so I've got a degree in astrophysics, so going to it, what it is that back in the 70s, okay, and we all have to do this, everyone going into astrophysics has to do the calculation that you start with the expansion of the universe and the age of the universe, where should it be? And you find out that it's out by an order of magnitude. You find out that the background radiation is out by an order of magnitude. You're finding all sorts of problems with this theory that there is an expanding universe or some sort of Big Bang. There's huge problems with it. And one of them is called the missing mass problem. The universe has to have about 10 times more mass, or else this whole theory of an expanding universe can't be true. Okay? So rather than taking a look at their original theory, which may well not be true, they're making up crutches, and all dark matter is really a crutch to try and validate a theory that doesn't match observation. That's what it is. And this is what we'd have over, and if you go on, doesn't matter, YouTube or social media, doesn't matter where you are, Twitter, Facebook, you see all of these publications coming out, and all these theories about all sorts of ridiculous nonsense, and you're realizing that it's based on things that just don't match observation. So like from science, we've got to observe and see what it is. You define what you're looking for first, determine what should be the result of that mathematically with a mathematical derivation, and then see it. If we see something that doesn't seem to follow that mathematical derivation, we've got to go back and redo the mathematics. We don't make something up to try and cover for it as a crutch. That's a classic example of sort of manipulating truth by just creating this strange, it's true because everybody says it's true. Okay, there's a vast number of astrophysicists that are losing a lot of faith in what we would call the Big Bang and the expanding universe, and dark matter is just really a joke. Okay, there's a lot of observational astronomers that say that, but you'll never see them or hear them because they would lose their jobs immediately. They would lose all their funding. They'd lose their jobs. They can't say that. It's a major crisis in physics. It's a major crisis in astrophysics. But you're absolutely correct. You're absolutely correct in what you're saying. It's a theory that to validate. It's a substance to validate a theory that doesn't match observation. Yeah. Okay, Joshua.
So in alignment with what you're talking about, don't you think a lot of that has to do with the way that Western culture has taken to science, and that you have many people who have made their careers off of popularizing scientific books for lay people, introducing these what they think are intellectually sexy and juicy topics to the reader, and that there's an enormous amount of profit and social prestige that is on the line for the invalidation of these theories. And because there are certain cultural and historical stories tied to the advent and the invention of the Big Bang theory, and the fact that it has been at the center of many debates between atheists and Christians and others, that it has so much social capital, that it's the social capital that people want to keep around for it, and they won't let it die. And that points to something that's very true about like our social nature tending towards something of an irrational thing whenever there are like more opportunity costs in the stories we tell. Because I think a lot of times that people, we think of science, like especially, I can say from my own experience, it wasn't until I got into a laboratory and I started working with mathematics and things that I really understood the difference between what the fields are as they are in terms of like the uncertainty that's inherently a part of them and what we're doing at any one time versus the stories people have or what a news article posits about physics. So there is definitely the story that the average person or people who are interested in science here, and they're becoming just as much fundamental to the conversation of what we think is true about physics because of the popularization of physics in Western media.
Oh yeah, very, very definitely. It's clickbait is now driving science. Clickbait drives the funding, drives peer review, drives everything. If you come out against, that happened with Halton Arp. Do you know the story of Halton Arp and the Burbages?
No, sir.
Okay,
No, sir.
well that's University of San Diego actually, and University of San Diego. She's still alive. If anyone's in San Diego and wants to visit a giant, it's Margaret Burbage and her husband George are two of the great astronomers who lived, and Halton Arp, who's passed now, and George has passed. They were postulating and putting out classes on alternative theories to the Big Bang and what was going on with the universe is not expanding and stuff like that. Halton Arp was blacklisted. He was actually driven out of the United States, was not allowed to go through, not allowed to use professional telescopes. He ended up in Europe. George was hounded. Margaret, who is a truly great astrophysicist, is really isolated as a result. So very definitely, where this comes from, it's actually a philosophy. When I was talking about Russell's paradox, when they derived these new axioms to try and save mathematics and so forth, one of the philosophies that were a part of that from Russell happened to be that you couldn't have an infinity. You couldn't have like eternity and infinity in the physical world, went totally against that. So really this Big Bang thing became extremely popular among this particular philosophical group that was putting stuff forward to save mathematics by saying that infinity cannot possibly exist and stuff like that, because the alternative is, of course, the universe is infinite and the universe is eternal. So the universe always was, the universe always shall be, and it's infinitely large, world within worlds and so forth, and there are properties to it, which is an alternative theory. Okay, but that cannot be accepted because I believe it's postmodernism. If people look at postmodernism, going to the depths and the foundation of postmodernism seems to get you to this point that you cannot have the infinite, and that the infinite becomes a real problem, and that's why the Big Bang theory is there to try and substantiate a philosophy that doesn't work, basically. But that's my statement. Sorry. Sam, you have your hand up. Thank you so much for being patient.
Sure. Yeah, very interesting stuff. But I have one question. You mentioned that you thought that science and the humanities, they are one thing. And, at one level of abstraction, I quite concur. The magisteria notion of Stephen Jay Gould, perhaps it's a good heuristic, but obviously, or well, not obviously, but at least in my opinion, and that of many much more storied people, we should still, at the end of the day, regard everything as falling within one universe, of which science is perhaps in fact, definitely is the most, kind of certain tool we have to shine a light in the dark, as it were. But nonetheless, over time, I've really come to feel that society is worse off with, the kind of greater turn towards STEM education and the incapacity of people, for example, to, parse rhetoric and, how, hyperbolic statements can be made and whatnot. And that doesn't have anything to do with, the postmodern philosophers. This goes back to really, ancient times, the trivium, classical education, which sadly has been co-opted for the most part by religious, people who are. But nonetheless, to kind of wrap up my point, I really feel that, trying to push as many people as possible into the STEM direction is kind of leaving society blindsided to things in which we have actually extremely low, quality of data. And the degrees of certitude that we can apply in sciences, 10 to the power minus 21 meter, if I remember correctly, was the precision of the instruments used for the detection of gravitational waves. And regardless of any controversy, but just to come up with that type of equipment and that degree of certitude, I mean, to say that, yeah, we can compare that type of, fine-grained, empirical data with what happens in human affairs is, seems to me something that can only lead to pernicious consequences. Thanks.
I thank you very much, Sam. It's one of the things that both Coyle and I were talking about, that if we go into an absolute thing where everything's got to be scientific and mathematically defined, we could end up with some pretty horrific situations. And basically, I've been saying that the most important thing is to have what I call the independent investigation of truth. That we have to investigate it ourselves and find out what's happening with ourselves. And people need the tools to be able to do that. A lot of times in the world, since the 70s, those tools have been removed, to actually be able to look objectively or at a particular problem and then be able to criticize yourself for what you may have come up with and things like that. It's the education has really taken a beating, I think, since the 70s. And since the 70s, it's just been a matter of dumbing everybody down because of political consequences that happened during the 60s. As I say, was a different type of education system. But thank you very much, Sam. I appreciate that. Cole, you were next in line, and then Joshua after you. And I put the earphones on so that I don't have an echo all over the place, because I just found out that while I speak, I'm ending up with an echo. So,
Yeah, I was not going to tell you. I was
well, it's very polite of you. Thank you.
Yeah. So, in the sense that, we're sort of wondering what the objective truths are, and I don't think that we should shy away too much from objectively being able to state certain things. Although I don't believe that, if you think that, defining something objectively is a problem, well, the courts and the government do it all the time. And, that's their job, is to translate philosophy and science and mathematics into the realm of human interaction. And, if people don't like that, then you have a problem with law and government, and you're on my side as well in that. But, in the sense that the legal system and the government has the job of making an objectively defined morality. I don't think that they have got it right, of course. Yeah. But I don't think that, say, defining terms of like, defining senses of like the set being like containing the empty set, or their cardinality being infinite, or other problematic logical steps that kind of that plagued kind of Georg Cantor, or like some of these other really genius people, has a lot to do with objective. And I think that what I agree with, I do think that there should be some sort of objectivity. But what I agree with more so, what you said before, was that we all know, we may not know justice, but we all know injustice. Yeah. And I think that that eliminating that from reality is probably the best, or basically the lowest bar to setting up a good morality. And like I said, I think that an objectivity has to be created. Say, like, killing people is wrong, that raping someone is wrong, but that also, certain things that are victimless shouldn't be punished to such a great extent for people who, kind of get the wrong end of the the truncheon, so to speak. I don't know. My question is, what's the axioms that you would say define morality? What would you claim as an assumption, or that you were forced to claim as an assumption, I guess is my question.
Yeah, it becomes very difficult when you're trying to put morality into a set of rules, because circumstances change everything all over the place. A set of axioms goes to a mathematical approach. And the universe, I'm saying the universe is a manifestation of the mathematics, okay, even though we may not know what the mathematics are. So I could come up with a certain boundaries of what is moral and what is immoral. For example, killing is one, which is the great philosophical argument, whether it's right to kill or not to kill. It's wrong to kill under all circumstances. What happens when the enemy is coming over and they're bayoneting pregnant women, in your neighborhood and stuff like that? Do you have to take up arms to defend yourselves? And it is right to defend yourselves. You can defend your country, okay, against invasion and various other things. But then again, is it right to all of a sudden send young men over to a place like Vietnam and kill everybody else, etc.? Does that then become right because you think you're, then defending yourselves, and then works out to being an incredibly immoral act? Do you know what I mean? So yes. We can try and play with this thing. And I like the fact you came up with the courts, because that's where the rubber hits the road. It really is. If we start talking about justice, how can we live in a society that has justice? Throughout the entire planet, everyone desires access to justice. We look for a political system. It doesn't matter if you have communism or capitalism. It doesn't matter if you have a slave state. It doesn't matter if you have an absolute dictator or completely democratic state. It makes no difference at all. provided the people have access to justice. And usually when you find that there may be a state, you say, oh, the political system here is absolutely terrible. There's no democracy, there's no anything like that. But we have a very benevolent ruler and everybody has access to justice. Okay. And that becomes like an ideal society, we would think. Okay. I think this point of access to justice is unbelievably important. Okay, so when we're talking about moral or immoral and things like that, I would have to say that it should be founded on what we would call justice. And as you say, well, how do we define when we know something is just? Well, maybe we have to do it the other way. We know what's unjust and keep trying to go along as we do, and our laws change and our societies change. And what we thought was a terrible evil, such as non-medical use of drugs a while ago, now we're finding this is totally the wrong way to go about it. It's a health problem, not a legal problem, and other things like that. So what is the more just way of looking at it? And in a way, you know, what is they talk about what is best for all, but what about minorities who are being destroyed, you know, to try and be of service to the majority? That's unjust, you know, other things like that. So I think in all, to answer your question, where I am personally, and I'm just sort of babbling here, but I would think justice is the key to everything, is what we would call justice. And I would be very hard pressed to try and define what is just, other than to say, I think we know what injustice is. I think we can recognize what's unjust.
Yeah, I definitely agree. I think that that you know, some philosophers have said to maximize maximize sort of good or maximize the benefit for the most amount of people. But I think a bottom bar to start from would be to minimize, you know, injustice or pain or suffering.
Yeah, because maximizing the most good for the most number of people ends up with fascism and ends up with Auschwitz and so on. That's the trick that is used to try and justify that. And you can take a society and you can bend them inside out. It can be done through language and through this, you know, sort of what we call political correct type of language and other things like that, which Eichmann used to delude an entire nation. Well, it's for the best of everybody that we do this sort of thing. You know,
I don't think it's necessarily fair to call what people's basically people feeling like sort of neglected and feeling like they want an upheaval, being that you know, it's the same thing for idealism, that oh, they were idealists and that's why they killed all the Jews. You know, like they killed all the Jews because they dehumanized them and they blamed them for all their problems. And you know, basically what they want is to be everybody wants sort of economic well-being, and they're kind of at each other's throats about it. But I don't think that being, say, defining a morality or being kind of an idealist, which I kind of define myself as, hopeless idealist, that is you know, justification, or that is always the grounds for more suffering. I don't think that can necessarily be a result. Yes, hand up.
Yeah, that's hi Oded. How are you doing, sir?
I'm doing fine. I have a question. In order to apply justice, you create many times injustice. That means being a judge, you create already immediately the injustice. And this is kind of thing that make me wondering. I mean, like a process, chemical process, when you create something, you prevent the process from continue. I think justice is kind of this kind that needs some equilibrium between justice and injustice. You can get it absolute.
I was thinking, yes, I see what you're saying. Like we usually talk about conservative systems. So if we have a justice, therefore there has to be an injustice. Okay. But there are systems which are not conserved. And it's interesting because I was looking at conservative systems and non-conservative systems. So we have the conservation of energy. Okay. Energy is conserved, can neither be created nor destroyed. So forget mass for a second and general relativity, but we talk about a conservative system. There are other things on the type and quality of the energy that are not conserved, okay, such as entropy.
Yeah.
If we look at something like justice, is it that justice or truth and so forth is not a conservative element, but our knowledge is continually growing and it's not conserved? Now, if we look mathematically at this concept of what's conserved and what is not conserved, okay, or non-conserved, they happen to come from a solution that's called, is it path dependent? So if it's path independent, in other words, I have the gravitational potential. I don't care how the object got into that state. However it got into that state, it has exactly the same gravitational potential. That's a conservative system. So gravitational potential is conserved, okay? But if we have something else, so it very much depends on the path you took to get to the place where you are, that's a non-conservative system, mathematically. And I'm thinking that as we go and we try and create more and more justice for all, et cetera, or access to justice for all, this depends on the path we take to get there. I don't think it's independent of the path we took. And that now brings in culture. It now brings in our history. It brings in our language, brings in everything else as to how we are able to bring about a more conservative side. So looking at your question, there are things that don't necessarily determine the opposite in order to happen. I don't think goodness is a conservative item. I think it's path dependent. I don't think that just because you have goodness, you therefore have to have evil in order for the goodness to exist. In order to have justice, you have to have the injustice in order to know what the justice is. I know Cole and I were talking about this. We may only know the injustice to be able to form the justice. So we kind of have to be aware of that. But is it possible to live where there is justice and there is no injustice? I think that is possible. But is it possible to live with injustice without there being some sort of just way of doing things? I think that is impossible. I think there has to exist some just way of doing things in order to have something called injustice to be there. And that, to me, means that these are not conservative fields. I don't know that's a very good answer, but that's how I see it.
No, I see the issue like when you apply justice, you create immediately injustice. Because you can say we is different people. So for one people, it may be justice, for other people, it will be no injustice. Because we can say that all the humans are the same. This is my basic assumption, that everyone is different. Therefore, when you apply justice for one person, you create injustice for the other immediately. So it's not the process of the way you go in, it's the process, the issue is the way you go to apply the justice. And this is my issue with that. Actually, it's related to my second question, which is about the green element. That means we want to live in a universe, or Earth, actually, so universe, that the amount of energy that apply, that everyone consume, is no bigger than the energy that provide us from the sun. People complain that this statement is incorrect. More people with more of energy footprint, when you sum them up, is more than the energy we can get from the sun if you take out the entropy in this energy.
Yeah. Yeah, so it should be slightly less than what we get from the sun. The sun reflects, but like the Earth is just an object in space. The only energy going in is from the sun. That's it. And there's some radioactive energy in the crust and things like that. That's all the energy we get is what's coming from the sun. So in reality, you're absolutely right. If we're and there's also the albedo. In other words, there's reflections. The amount of energy is left over and so on. But that's all the energy we have. Okay. And if we're using up more energy than what the sun is giving us, and we're headed for disaster. And that's exactly what's happening.
So what do we do about it? Everyone wants to say solar panel, but I saw I work in this area. It's really not very efficient solution. It's actually not a solution at all.
Yeah, this is because we're dealing with things in a piecewise way of doing it. In reality, if the only way we can, this is a global problem. It has to be solved by globally. We have to have something in place where the planet itself is able to unite and work together. The pandemic that we just had proved it to us. We know how to save the planet, and that just came out of the pandemic. everybody locked it down, and all of a sudden the planet started healing. Everybody was locked down. So people just stopped driving their cars for a couple of weeks, and or a couple of months rather, and lo and behold, the planet started getting better. I mean, you could, the air in Los Angeles became clean. Okay, dolphins swimming in, Venice, because everything shut down. Oh, we can do this, and we can do it as a planet. So unless we unite as a planet and do it, whichever means that is, I'm not going to describe how to do that, but if the planet unites, do it, we can actually save the world. The world can be saved. We can save the ecology, and that can only happen if we unite the planet. And personally, I think the only way we can unite the planet is if there is universal access to justice. I think that's the first thing we have to start with. But that's just my approach to it, to answer your question. But it is possible to save the planet because we've just done it. We've just seen a direct result. Sorry, Cole, you have your hand up, but go ahead, Oded.
I think the only way is to reduce the number of people on the world. So if you want to keep some minimum energy footprint, and you know how much energy you get altogether, it's simple math, not very complicated. You can say, in order to do it, we have so many people in the world. Now the justice, who will be and who will not be in the world. And this is the justice, my opinion. And some people said doing it is, I think doing that is the issue of creating injustice, because we have the right of propagation.
Yeah, there's a book out by Mamdani called The Myth of Population Control. If you're interested in population control, have you read The Myth of Population Control? Because just running out and killing a whole mass of people is not going to work, because you'll just have everybody come back again. We're seeing what's happening with the population drop in Japan, which follows exactly as Mamdani was saying, in certain ways of dealing with population control by giving people access to the means of production. Is the way he's proposed. As you have more control over the means of production, population drops drastically. The United States has had negative population growth for a long time. So has Canada, had negative population growth. Most of the developed world has negative population growth, which is why all this immigration is coming in, because they want the population to increase, but it's not. So in a way, I think we can reduce the population. I think it's going to reduce anyway. I think that's going to happen as a natural consequence as the world develops and so forth. But that's just my opinion. That's my opinion in response to what you're saying. Cole, you have your hand up. I'm sorry.
Yeah, I want to jump in on the conversation a little bit. I sort of was on the side of Oded. When you say that you have if there is a defined justice, that you have somebody who doesn't benefit, or somebody who you make injustice as well. That sort of you kind of have to have, or if it's beneficial to have a system that outlaws murder and that is effective and that is for the benefit of the person that has committed the murder, and also the person who has been the victim, or the family especially, that you should try and do that. And basically, I think that there is still a possibility for injustice even in that. Like, people can get wrongly accused, and that's not to say about people who were, say, like being biased, like, or biased against, like, in terms of maybe racial or some other like minority perspectives that are just outlawed at the time. I think if you eliminate that, you still have the injustice of the wrongful accusation, which will possibly persist no matter in what system. Say you have like a anarchist system where everybody takes accountability for for everybody in the whole place, then you have kind of like these people who could possibly wrongfully accuse, even from a non-professional or untrained viewpoint. I think you're still always going to have that. So to complain about that is kind of like just like the inevitable. Like it's gonna happen, and you have to minimize that no matter what. And I think that they're not also implementing that in our country. They're not implementing the what is it? Beyond reasonable doubt. I think that they abuse that a little bit in our country, and you know, a lot of times where things are beyond a rational doubt, you know, they're accused still. So, or no, yeah. So, you know, I think that the fact of defining justice still doesn't take away from the fact of their approaching one. For path dependent, were you saying, is that when things fall into gravity? That things grow a greater like velocity or potential energy?
Yeah, it's a mathematical concept called potential, where you have gravitational potential. Potential is the ability to do work. So when an object, it takes work to move an object further outwardly in a gravitational field, and it just depends on the distance. Doesn't matter how it gets there. The amount of work adds up to the difference in the distance between the attracting body, you know, as you're moving away from the attracted body, or you gain energy or and so forth by a body falling into a gravitational field, which is only dependent on the distance that it's traveled towards the center. Doesn't matter how it gets there. When you go from A to B, the gravitational potential has increased from A to B according to the absolute distance, whether you go in a straight line or whether you go anywhere around. That's called a conservative field. So gravitational potential is conserved. Okay.
Yeah.
But then there's other things that are definitely not conserved and are path dependent. It's a property of mathematics is how it's defined. Then it comes that if it's path dependent, if it depends, if we have an object, it very much depends on how you got there. Okay. And the whole history of what you went in the path to get there. If you have that, that is not a conservative field. You're not dealing with conservation of whatever it is in that field. I was using that as a mathematical example.
Yeah, yeah.
Whatever it was I was trying to say. Sorry.
I kind of latched onto it a little bit in that you know, you saying that justice is a non-conserved system and path dependent, that justice is a gravitational force that the you know, the legal system is orbiting around.
No, I don't quite think I didn't compare justice to something like gravity. Justice is like it's like knowledge, and we gain more and more knowledge with it. And knowledge, I don't think, is a conservative thing. I don't think we create ignorance the same time we create knowledge. So I understand now what Oded was talking about. As soon as we create a justice system, we try and have justice, we immediately create the possibility of having an injustice, or having immediately, as soon as we do, there can be a miscarriage of justice, as you're talking about. So as soon as we have it is illegal to kill, we may have a miscarriage of that justice. We've created that immediately. It is now possible for that to happen, for there to be a miscarriage of justice. Now, I think that, you know, I'm now understanding more what Oded was saying. So, you know, which I can see that's a fairly obvious statement. I agree with that. Joshua, you have your hand up and you've been very patient in the background. Thank you so much.
Oh, no problem. I mean, I like listening to people, so I mean, I have no problem with it. I'm going to just say, iterating something in alignment with what you're saying, that definitely whenever we're evaluating what makes sense in terms of social outcomes, we do have to pay attention to the effective material consequences of what we observe with people. And like, if you establish a value and you say it's good to do something, because like Oded said, there are differences in people for various reasons. And these differences lead to the effective outcomes that people can achieve, even with certain things established. So you're an astrophysicist. It's very, there's so many studies to show that whenever you're looking at, say, the people in STEM fields that are awarded with various degrees, that the IQ is average at about 140 for most individuals. It seems like that there is a prerequisite, as is for people to be differentiated in certain ways that are somewhat random and haphazard, that do lead to the effective performance outcomes of certain individuals in the world that really can't be controlled in any precise way. And because there is an inability to control so much of what human beings turn out to be in the end, because I mean, even literature on psychopaths, for example, people who are psychopathic, it's just kind of like an accident of nature. They don't choose. Nobody chooses to be that way. Things do probabilistically line up in certain ways, and outcomes do happen. And these individuals are more likely to do things like violent crimes simply because their nervous system is set up in such a way that they don't feel guilt or shame. Why nature engineers or allows for people to emerge that can't feel guilt or shame is not anything that seems to have a definite reason, but because we are a part of an ever evolving process, things will spin out and spill out of the human population that cannot be accounted for, because the even ways in which we understand anything from behavior or genetics to work is very nonlinear in its makeup. Whatever variables are there and the ways in which they relate to one another has as much to do with the way things look as anything else, and trying to get down to the bottom of these things so that we could come up with a precise understanding of, what should we say that everyone should be doing, or what can we come up with that would not exclude a group of people or a class of people. Because even say communism as a system, that probably favors more agreeable people than not. Just a personality dimension could have an effect on how well somebody can abide to a set of moral or set of values. And personality and other traits are not things that really we can engineer in any definite way. And when you get into the question of how much can it be something that the material or effective consequences of how people live in the world is something that can come down to what we engineer in terms of our ideation is kind of not clear, because at least to me, it's not clear because how well, or because there's got to be evaluation. Whenever we're looking at one another and we're determining whether we are moral or we are good or we are right, there has to be some kind of effective truth we know out in the world, and based on the material consequences of our actions. What can be seen as an effective material consequence as going towards something that we say is good is in some ways predetermined in terms of a most expressed outcome. Can a disagreeable person be as altruistic as an agreeable person? Can any of these things be like, always you're going to get this? And it doesn't seem like you're saying under chance and circumstances, many pluralities of ways of understanding things do emerge. And that seems to be true even with the path that we choose, because path that one takes has to be known from like, well, what do we see as something that is communicated to us? And what is communicated to us, doesn't that have to be something that's intelligible to our system of salience or relevance? And doesn't that have to have some dependency on what we prefer and like as the things or the individuals we are? And don't we always have some regression of difference in complexity from each person to each culture? Because it seems like that's the bent of nature, to have similarity while having as much variance within a population at the same time. And so are we going to really be able to get there in certain ways with our human enterprise, given the things that human beings are as like the material things we are in the world?
Yeah, one of the things as you were speaking, just to complement what you were speaking was the idea of education. A great social experiment of the 20th century is to instill compulsory, institutionalized, free education for all that was compulsory. There's all sorts of interesting philosophical conundrums that you can get into that, like what exactly are we teaching? We're going to take an entire generation of children and bring them up and teach them all sorts of things. And like, what exactly are we teaching them? And is that an immoral thing to do? Like I've done an awful lot of teaching, in schools and so forth in my life. And I say it's one of the most immoral professions of all. We're going to take you and we're going to force you to answer an exam. We're going to force you to learn mathematics, even though you don't want to. It doesn't matter. You're going to learn it, etc. But I do that because I know that opens doors for students and things like that, and it has all sorts of complexities to it. So while you were speaking, Joshua, I was just thinking this point of like looking at can we deal with education, and does that also impact something like what we're actually trying to mind control, if you like, a society, and so forth, which all depends on things. Okay, thank you. Ratchet, you had your hand up, and thank you for your patience and listening to us. The floor is yours, sir.
Thank you. I've been enjoying the conversation so far. But as the saying goes in philosophy, it's hard to talk about anything without talking about everything. But I was trying to relate the conversation back to the topic of your talk, right, with the existence of numbers and things like that. So I was hoping that you could maybe close that loop a little bit for me. But the other, in that spirit, you had mentioned that physics flows from math. It's not math that flows from physics. I tend to agree, but how do you account for the fact that our math of the universe doesn't actually fit the data exactly? It seems to just be kind of like a mean towards which reality appears to converge.
Oh, thank you so much. I guess it brings it back to the topic. I think the underlying fact is truth, is looking that truth exists, and to define truth is that which exists independently of our perception. So that's how I'm defining truth, and that truth does actually exist. And we can get to that, from mathematical foundation. Looking at the universe and the laws that we have, like from the three differential equations I was talking about, electromagnetism, gravity, and quantum mechanics. Quantum mechanics is an interesting subject, and I don't think very many people have read Schrodinger's 1935 paper, but it's a brilliant, brilliant paper. And a lot of stuff we hear about quantum mechanics, which you're saying, well, science doesn't quite sort of describe. It does, because there's certain areas where we can't have a measure, or what we call a Banach space, or an actual measure. So we create a purely mathematical model to describe what is happening. Or Schrödinger said in his paper, there is no such thing as a physical model for quantum mechanics. You cannot have a physical model to describe quantum mechanics. He's absolutely right. The model we have is a mathematical model. You do the equations and it determines what will happen with the predictivity of what's about to happen. So that happens to be there. So, but our knowledge and our perception is not complete. So there's going to be all sorts of stuff we don't know about, and all we have to go back on are these equations, which so far are good. We have a problem, for example, in crystallography and so forth, that in larger crystals that are having problems and things like that. But that's really because of what I'm saying, the model, the mathematical model in the beginning may be completely incorrect. Okay, like Niels Bohr's interpretation with the Copenhagen interpretation, Schopenhauer completely destroyed that, went totally against it. And yet we come up and we look at this thing is coming in a lot because of that interpretation. I'm bouncing around. I'm trying to say that, you know, the truth actually exists. Truth is that which exists independently of our perception. And then again, all we have is our perception. All we have is the ability to try and take and to be able to model what we see in a mathematical way. Because everybody does mathematics. It's just that I'm defining mathematics in a certain way. But if you happen to be Blackfoot, or if you happen to be Salish or Coast Salish, or on the West Coast, you know, in the big house side, you would have a completely different mathematics and maybe a totally different view, and you model things differently. But if you take a rock and you drop it, it's going to fall to the ground, no matter where you are, you know, no matter what culture you are. Does that help, Ratchet, in what you're saying?
It does a little bit, but even if we just ignore the quantum and just focus on macro phenomena for a second, I'm getting a bit of a Platonic sense from what you're talking. Like, you know, reality is actually the Platonic reality, and what we experience is a manifestation of that. It's not the real reality. And, you know, I'm sympathetic to that view to some extent, but take a macro phenomena like the position of bodies in space, right? Large bodies in space. We have mathematical models that kind of give us predictions of where they ought to be at any given time. And those models give us, within some sort of a margin, a pretty darn good idea of where they're going to be. But they're never exactly right, because the models don't account for the full set of variables that are interacting, you know, with these bodies, right?
Absolutely,
and so
agree with that totally.
So I'm wondering if it's in principle, you know, not possible to build the all-inclusive mathematical model, because there's an infinity of interactions that you would have to account for in your equation, and you just inevitably going to abstract something away for the sake of usefulness. And I agree that usefulness is a really, really important concept. But I'm wondering then, is the mathematics really the reality, or is it just an instrument for us, rather than the actual reality?
Oh, awesome. Now, okay, thank you so much for filling that in. Yeah, it's called precessions and you know, various other things, perturbations. Okay, all come into like trying to describe, you know, something very simple like the Earth, Moon, Sun system. It's not going to be consistent. All sorts of different things come into it. There's perturbations with other, you know, asteroids that go by and comets that go by and things like that that's going to disturb the system. And nothing, you know, every single thing within it can only be predicted to a certain extent. We have the weather. It's a classic where we're getting to chaos theory, where you have the weather is being described by a mathematical model, and you end up with a butterfly, you know, flapping its wings in India will create a tornado in Kansas, for example, this sort of thing. Yeah, there's the restrictions that we have in what we can know. But just because we need an infinitely large, and we do have mathematical models that create infinite solutions and so forth that are still quite useful, because we can take the ones that are dominant, you know, and that becomes very useful to us. So we can actually do that. But yeah, I'm saying that it's also deals with something. We usually look at things like time oriented, or what is the causation. We think something has caused something and something happens later on. So we may see, well, the mathematics then actually created the universe. It's not really what I'm saying. Is behind the universe there is this unseen blueprint, we'll call it, that the universe, because there's order in the universe, the universe has to have a blueprint, okay, that is that order, that represents that order. So there is a blueprint to the universe, and the blueprint of the universe is mathematics. Yes, Ratchet, sorry. You had your hand up.
No, that's, sorry, I forgot to put my hand down.
Oh, okay.
Thanks for addressing my points. Really interesting. Maybe my last question would be, when you say that, for example, you distinguish between the existence of something and reality. Can you elaborate a little bit on that distinction, and in what sense does a number exist exactly?
Okay, is a number like a part of physical reality? No, I wouldn't say that it is. But then we have to define what we mean by physical reality. The number that we have is like really space-time. Let's say everything just exists within the space-time continuum, but the space-time continuum is a coordinate system, and it exists. It has length and it has time. These are properties of the space-time continuum. I have no idea why it has these properties, but it does. And therefore, in that way, yes, there are numbers, and yes, numbers exist, but it's not the same as a stone existing or a rock existing. It's the potential. Numbers in the mathematics form the potential, which is how we see reality, and reality is a result of that, of the space-time continuum doing what it does, following the laws that it does. And these laws and so forth contain numbers or mathematics. If you use mathematics with numbers, because there are mathematics that have no numbers, such as Euclidean geometry, have no numbers, really. You can count things. It has magnitudes. Numbers is defined as a magnitude rather than by number. In our modern world and in our culture, we define numbers according to number defined as accounting. However, there are other cultures that define it as a magnitude. And that's a different way of looking at it. So I'm not answering your question directly because I don't really have a direct answer for that. But I would say that if I'm talking about reality, I'm talking about physical reality. But by the same token, numbers are real. Numbers actually do exist. Even imaginary numbers, they actually do exist. And they are just as real, but there's a different consequence to that reality. I'm sort of falling all over the ice here and trying to
it's a tough subject. The reason I ask is because in other discussions that we've been having in this group, this has been something we've been wrestling with a lot lately, is, existence, the nature of existence, whether existence is a predicate, whether it's the subject matter, if ultimately, because when you use the word manifestation, you're kind of assuming existence as the subject, and it manifests some sort of, presence of some kind, according to some principles or whatnot. And we've been trying to, figure it out. And philosophers, for all their rigor, have been kind of sloppy about their use of the word exists, and differentiating between being and existence, and how to deal with abstract entities, how to deal with imaginary entities, how to deal with false propositions. And you touched on it with the null set, for example. If the null set exists, well, what does that mean? And do the members of the null set exists? And all that stuff. And I guess there's some mathematical work that's been done there. But I'm trying to tease out some of the philosophical implications, because when we say that something exists, we're saying something about it, but what is it in virtue of which it exists? And that's what we're trying to get at, I think, fundamentally.
Yeah, I think it's very, very important. Thank you so much for giving that background, because I'm new to this group, and when I'm seeing things like potential, well, potential is a thing that actually exists, but it doesn't manifest itself, let's say, into the world of being or the world of reality, because it's just a potential. For example, if this helps, we have when we have a coordinate system, there exists along the lines of this coordinate system something called tension. And that's a result of curvature. So if we take the ruler and we bend it, it's going to create tension in the ruler. And this is basically the Einstein field. General relativity is on a very simple term. We have a ruler that's a length. It's a measure. We bend the ruler, and now we change the measure of the length. But what causes the ruler to bend? Because the stresses and strains and shears within the ruler itself that cause it to bend, or I can have stresses and strains in the ruler, and the ruler then bends. But basically, because of this bending of the ruler and so forth, which creates these stresses and strains, if we bend it enough, basically what happens is this ruler, through quantum fluctuations, creates a particle, what we call a particle. So a particle is really just a knot in the space-time continuum. And I'll refer to that as the world of physical being. But that does not deter from the fact that if we have something like a photon, which is just a disturbance of the space-time continuum moving at the speed of light, or through the space-time continuum, is there an actual thing that actually exists? Well, the wave exists, the fields exist, and stuff like that. So I'm really trying to, I know what you're saying, but I'm hammering down existence as a physical existence. But what's behind the frequencies of the light that actually makes light happen, the electric fields and stuff like that. That's a whole world of mathematics, which actually results in light. Or it doesn't result in light, but that is behind, if you like. It's the difference between having a causational thing, if then type of way of thinking, versus when you go into the calculus, first thing you have to do is get your head around the fact that it's not causational, it's what's behind sort of it exists along with at the same time as the event that is happening. The cause and the event are one and the same that is happening. One is just a potential that manifests itself into an event. That's what I'm talking about with a manifestation. Okay, that this, you bend the space-time continuum with enough energy and with quantum fluctuations, you create an actual particle, like an electron or something like that, that can appear out of nothing. It looks like it appears out of nothing, but it doesn't. It has to have an amount of energy to be able to make that happen, which can happen. So I'm going to a very strict sort of physical way of looking at physical existence. And does a number exist? Well, yes, it does, but it comes through this idea and concept of potential. The mathematics hangs on this idea of potential, which exists within electromagnetism, which exists in the Einstein field equations, and exists in quantum mechanics. Okay, it's constant throughout that you have this manifestation of potential. So I think if it helps with the vocabulary that I can bring in, is the idea of potential, rather than the idea of it's either there or not, because potential can approach a certain point, and then all of a sudden when it hits the point, it magically appears as being something. But it was working its way there for a while going into that in the example that I've chosen. And of course, all allegories and all examples have, aren't, perfect or anything like that. But that's about as, maybe that helps a little bit. I don't know. Okay, Cole was first, and then Oded, we'll jump back to you, please. You're muted, Cole.
I saw some interesting definitions of number in mathematical philosophy by Bertrand Russell. Piano apparently has some really rigorous definitions of what a number is. And other definitions you'll get are based on like limits and convergence, which aren't very satisfactory. But basically in Euclid, a number or a point is that which contains no space, right? Or has no part. So basically a number is kind of like nothing. It's like, it's almost not there. It's such an acute or precise measurement that it can never be reached. But it serves as a demarcation to, say along said ruler, or the scale, to measure the actual point. So it's almost like a number is a name, and you can call it like what Bruce was saying, like orders of like numbers, or quantities, or however you want to define number. But Bertrand Russell pretty much gives a basic definition for it, something that's like satisfactory. And I was also going to say about the existence, what you were saying about proving existence. A lot of times with like logic and stuff, I think, well, the math doesn't necessarily, math works for physics and stuff like that, but with philosophy, the logic is what mainly works out, which was discovered by a lot of mathematicians and philosophers at the same time. But that if you say something exists, you also have to say, well, if you say it exists, and then you also say this statement is true. You know what I mean? So in order for you to define existence, you have to like kind of like go further every time. Like if you are proving something, like say Socrates said that he knows the most because he knows nothing. Okay, well, if you want to prove that statement, you also have to include that, it's something that Socrates said and that he assumes to be true and is accurate during whatever time period. You kind of have to put a lot of qualifying. You have to be as precise as possible sometimes with the logic, is what I noticed a lot of the times where I was working out. And I think the logic is what's most interesting. But I was going to ask, do you think you could put logic in a functional framework, meaning that predicate logic can take domain to range and be defined as a function?
Oh, yes, yes, very definitely. I think that what you're saying is also, if you're trying to define if something exists or not, you have to define what it is that you're trying to determine whether or not it exists. Dark matter is a classic. You can't prove that it exists as a dark matter. Nobody knows what it is. All that is happening is you say we see stuff that we don't understand, therefore it must be dark matter because dark matter explains everything that we don't understand. Okay, so this, it doesn't, it's absurd. Okay, we get into what's called the absurdity of this thing. So if we're going to define, do numbers exist? Well, first, let's define what a number is. So I've defined number, and that comes out of the Principia, by the way, of Russell and Whitehead, where they define a number through this matching process I was talking about, you know, of cardinal versus ordinate and so forth. That's the def. So I've used that. Well, the null set is the set that has no elements. Therefore, the set of the null set is the number 0, which, and if the null set exists, and it's usually assumed that it does, no, it's not assumed that it does. It's actually been proven that it does exist, being the set of no elements. So we can start there because I'm not going to create any controversy because most of the world of mathematics agrees that the null set does actually exist. Well, once we get to there, now because the definition of what a number is, we can show that a number exists. Yes.
But okay, so the sort of that 0 is the set of is the, what is it, the null set? It's not exactly.
It's not the null, no. The set of the null set equals 0.
But it's not necessarily, that might be like a philosopher mistake because it's not necessarily the set of the null set, it's the cardinality of the null set.
The cardinality of the number 0, not the cardinality of the null set. The cardinality of the number 0 is the cardinality of the number 0 is the name of the set of all sets having no elements. That's the null set. It's the set of the null set by definition.
Okay, yeah, see, the way I was thinking of is that cardinality can only be applied to sets. So you basically say that the cardinality of 0, which is a set with the only element is 0, the cardinality of that set is 1.
That's right. That is correct.
So
if you have a set of 0, that is the number 1. The set of the null set is 0.
The cardinality of the empty set is 0, right?
Correct. Yeah, in that way, yes. Yes. You got it. Yeah.
That's what I think is more accurate than what they possibly were saying. I mean, I don't think the set of the null set is 0. I don't think that's necessarily an accurate notation.
Okay, that's fine. But we were taught, like I say, we're only grade 7, so you got to get it, you know, the best as possible. The set of the null set is 0, guys. That's you know. Oh yeah, now we understand it. That's just the notation. Okay, it's the language and the notation of how we write the symbols. That's a language, and culturally we accept that the set of the null set is 0, but the cardinality of the null set is 0. Absolutely correct. The cardinality of the set of the null set is 1. Absolutely perfect, because the number 0 actually exists. Now you got the number 1, then you got the number 2, and now you got the number 3, etc. That's okay. That's what we're talking about.
Interesting. Okay. Yeah, I think I just might have stumbled upon it accidentally.
Okay, thank you. Oded, thank you for your patience. You're muted, sir.
Okay, I have some concern. There are the people that lived 200 years ago, the physics and all the philosophy was different than we have today. Definitely. And I say, what happened in 200 years from now? How we judge ourselves? Are we be the same people that we will look at the people that we look in the past that said the earth is flat and therefore a big turtle that support it? That means what we think today is we think they are the smartest human in the world that know everything. But what happened in 200 years? How they look at us? And does our philosophy and math ready for going towards the future? Is some opening to what would happen in 200 years?
Yeah, the problems of today are different than the problems were 200 years ago.
Yeah.
200 years ago, slavery was accepted. okay? Today, it's not accepted. And it can't be accepted because the world is different. We have different global problems. We could not have the world. Capitalism right now has supported a rather large number of people throughout all the world. 200 years from now, it may be considered just unbelievably immoral and reprehensible, okay? But right now, it's how we live. Because the world's problems are different. We have to, like, there's a practicality to it as well. How are we going to live? I work in the oil industry sometimes, so I have to deal with things in the oil industry. So what is the moral implications of extracting oil so that people can drive tractors and grow food? Because if we don't have this system, millions of people will have to die because we can't feed them. We have to use the system, but then we look at the redistribution of the food, and that's completely corrupt and immoral and so forth, which we have something like a pandemic comes in, and all of a sudden our whole supply system, our methods of supply system completely collapse because it's unstable, because it's not, it rests on something I call integrity, and you have to have integrity for something to actually work and last and stuff like that. So it brings in a different way of looking at like what integrity is. To me, integrity is like a engineering problem, okay? And it's a way of putting morality into a very sort of practical view. So what keeps a bridge up? The integrity of the bridge. If a bridge has no integrity, it'll collapse, okay? It's the integrity of the material, integrity of the design, integrity of who built it, integrity of the people who maintain it and use the bridge. But if the bridge doesn't have integrity, it'll collapse, okay? So what keeps an economic system together? An economic system is the financial transactions between members of that economic system. If the financial transactions between members of the financial system do not have integrity, the entire economic system will collapse globally because there's no integrity to the system. Okay. So
In the future,
in a way, I can say that it has to be what works. So what has integrity and what does not have integrity? Okay. Like the slave trade is completely immoral. But then there were societies that had a totally different way of looking at slavery. It's like with Mexico with the Aztecs, where I could be your slave for a year because I, let's say, stole a loaf of bread, so I'm sentenced to be your slave for a year. And then after I've worked that off, you may, kick my dog, and then you become my slave for a year, okay? And that's how they ran the slave trade within the Aztecs. But the way that the slave trade was done under capitalism and the Industrial Revolution was horrific. It was absolutely repulsive, okay? And, I'm not, so yeah, our moral values will be changing in 200 years totally because we'll have totally different problems.
because my question is, not at the more in the year 2525, familiar with this date?
Yes, I know the date, yeah.
2525.
Yes.
My question, in this year, does our moral value will be different, and our science will be different? Maybe you can have fusion to get energy, which is now gives us unlimited amount of energy, maybe. And all the physics law will be different. Do we open the gate or the trail for 2525 in science, in philosophy? Or we just doing what is done in the last 2,000 years or 5,000 years?
Oh, okay, I'm going to go on to Richard, but just to respond, there is a saying from Ecclesiastes that there is nothing new under the sun. So everything that we're discovering today was discovered long ago and people knew about long ago, but it's totally different at that time than what we know now. And in the future, people will be rediscovering things. I'm bringing in a Blackfoot idea, or something I learned from the Blackfoot, which is that knowledge is a living thing and never dies. Once knowledge is found, it will never die. You can't get rid of knowledge, okay? And it's a living thing. It becomes a part of the continuum that is around us. And that's sort of a very sort of mystical way of looking at it, but I find that it is a very useful and good way to look at things regarding what is happening regarding knowledge and how we have knowledge about things. I'm sorry, Richard, your hand's been up for a while. I'm sorry, I'll get to you. Thank you, Oded. We can get back to it and give you more time there. Hi, Richard. You're muted. Good.
Hi. No, I agree with, like, I guess I haven't thought of using that word integrity, but, I definitely agree that separately, that, like, the values of our economic systems are leave a lot to be desired, I guess. That's the best way I can put it for this. Like the really kind of disturbing part is that, chattel slavery is still in our economic system right now. I mean, like, they're just kind of abstracted away behind other layers and kind of in distances where we can't see, like the shrimping industry in Thailand and whatnot. I guess, like, kind of looking at our supply chains and how they kind of quickly, like failed and collapsed. I guess, like, the way that I had the lens through which I had kind of been looking at them previously was, I guess, similar to like Taleb's, the writer, his kind of conception of like anti-fragility. That some systems like that have resilience, that are able to kind of withstand shock, can be described as anti-fragile. And definitely what I've seen over the last few decades is like this ruthless drive towards efficiency, kind of at the expense of all else, like, because that serves to further and further concentrate power and capital. Like, that's left like very little room, very little margin in our supply chains and our economic systems to handle shocks, like from studying just even like just kind of like basic computer architecture, like in an undergrad class, I remember, like, ages ago, kind of a pipeline architecture, which can be aptly kind of used to describe our supply chains. One of the weaknesses is getting the error handling correct. And I've kind of in professional work kind of seen examples of that handled poorly. But now we have these like complex supply chain systems, right, which that's basically been an oversight, or just basically just cast aside, like for the sake of quote efficiency.
Yeah, one of the things that I look at when it comes to integrity is a personal and individual decision in relationship to others, or in relationship to around. It comes from something that I call service. This is something that I get into and so forth. And of course, I haven't built the whole thing up, but like, you're either in service to others, you're either trying to get everybody else to be of service to you, or you are dedicating yourself to be of service to others. So when push comes to shove, and this relates into fields over what we call stable equilibrium and unstable equilibrium. The whole economic system is based on what we call a zero-sum game, and that creates a global unstable world. And basically, because as soon as it collapses, the unstable equilibrium is defined as when something goes apart way from the equilibrium, becomes more and more of a failure. A stable equilibrium is when you have basically you move away from the equilibrium point, and the whole system immediately goes back to the equilibrium point. For example, you take a bowl, upside down bowl, you try and balance a marble on top of the bowl, and if the marble rolls off, it's going to continue rolling off. If you turn the bowl upside down, put the marble in there, it'll stay there. If you disturb the marble, it'll go back to it. That's a stable equilibrium. On the side, unstable equilibrium. So the world is based now on everybody trying to get everybody else to be of service to themselves, or trying to control everybody else. Everybody's trying to control everybody else, and no one can control themselves. None of these people can actually control themselves, and that's the state of the world. Whereas the opposite would be if everyone's trying to be of service to others, even though it may be to their own detriment. So if we have a planet, let's say a theoretical planet where everybody's of service to other people, rather than trying to get other people to service to themselves, now you create a stable equilibrium. The whole planet stabilizes immediately. Okay, that's if we start with that premise. How we get to that, I got no idea. But nevertheless, that's what I'm talking about, Richard, in between stable equilibrium, unstable equilibrium. Whether something has integrity and will last or not depends on this thing that I'm calling being of service to others, or getting others to be of service to you. Okay, and as your primary premise. Philip, did you want to have something to say? I know Cole's just jumping at the bit here. Sorry.
So just want to clarify, when do you want to end this talk?
I don't know. We got the rest of our lives. When do you want us to end it?
Okay, so I mean, we can end it. What about this? Ending at 10. And then I can talk to you. I want to talk to you a little bit about logistics.
Okay, because I'm using a different system. I know that you had made the comment that we're sort of bouncing around all over the place, but I'm using a type of system known as consultation, where you know we can go off topic, we can bring in things and stuff like that, and then we follow that path, and then someone else may come in with something else. Okay,
Yeah.
So I'm using that system basically from a talking circle type of thing to a basic consultation. So on a try to make the field as level as I can so that people can speak and have their say. I'm just about at the end of it. I'm sort of running out of energy myself.
Yeah.
So I'm getting there. But Cole did want to actually say something. So Cole, I'll let you take a shot at it. And then I think maybe we'll wrap this up. And if someone else wants to make a statement, a lot of people have left already because it is getting late in some places. So get your hand up if you want to say anything.
So what I would want to say is that maybe after this, I want to give you a talk, me and you just privately talk a little bit. But that's pretty much it.
Sure. Yeah.
Right.
Yeah, I was interested in the zero-sum game and the stability analysis of the equilibria. Is there a game theory and differential equation link? That I mean, I'm a huge math guy. So
yeah, actually there is. It's John Nash. It's called the Nash equilibrium. The stable equilibrium that came to the world was basically through John Nash, who actually won the Nobel Prize in economics because of that. And there's a ton of mathematics around it if you want to read it.
It's like a partial differential, isn't it?
Yeah, there are partial differential equations that describe it, and the geometry that describes it, and stuff like that over surfaces of manifolds and stuff like that. It's highly mathematical. As a matter of fact, I did actually have email conversations with John Nash before he passed away, and we were discussing ways of basically solving nonlinear differential equations and stuff. It is quite interesting. He was saying, don't believe anything, because he had come up with, I read of a theory that he had come up with. So I contacted him and says, did you actually come up with this theory? He says, no matter what, don't believe anything. Even if it's been published with my name on it, don't believe that it came from me. Okay, which I thought was great. And so we looked at this. No, I did not come up with that theory and stuff. Okay, thank you. But I looked at that, but I've been fascinated by the consequence of what he's saying, because with a Nash equilibrium, it means if you and I make an agreement, okay, we make an agreement of such a way that if we move away from that agreement, you will do everything you can to get back to that agreement. If I move away from the agreement, we get everything back to move to that agreement, because that was the agreement. Okay. And we both, that's a way of meeting the agreement. That's a way of negotiating. I look at your needs, okay? I have to find out what are your needs, and I try and fulfill your needs as best I can. And you are trying to fulfill my needs as best I can. Because if you don't fulfill my needs, I can't fulfill yours. If I don't fulfill your needs, you can't fulfill mine. So that's how we're going to work together, okay? So if I all of a sudden see that you don't have what you need to meet the agreement, I will do what I can to get you what you need so you can meet the agreement. Do you understand? That's how that system works.
I understand the principle of it. I'm highly interested in it. I should read more about it. I'm embarrassed that I haven't.
The Nash there's a ton of stuff on the Nash equilibrium, a ton of stuff on that. The opposite is, of course, a zero-sum game. And often I go into a math class and I'll do a very simple zero-sum game, on the board, which is just a simple game on the whiteboard, and the whole class will be erupting and rioting after a little while, because I use girls against boys while we do it and stuff like that. And but every zero-sum game has a trick to it. There's a way to win every single zero-sum game if you know the trick. And that's the problem. Everyone's trying to find the trick so they can control the game. And we're talking global economics here. So there's some pretty powerful players in that, and it is not a healthy situation.
Where does the prisoner's dilemma fall into maybe even a partial differential equation like analysis, or is that basically
I'm not familiar myself. You'd have to Google it, look it up, and see where that would come in. But if you read the Nash equilibrium and John Nash's stuff, there's a ton of mathematics in there.
Okay, thank you.
Okay, same thing like the white paper on Bitcoin, which is another thing. There's a ton of mathematics in there that makes it work. Okay, Richard.
I was just going to quickly respond. or I was going to mention about the economics and kind of being more cooperative, but kind of quickly on Cole's point, if I find the YouTube link, I'll paste it to the chat. But like you can find like even just a kind of a non-mathematical understanding of the Nash equilibrium, like in regards to like I'm trying to pronounce it correctly, Hotelier's spatial competition. It has to do with like why like all like furniture stores, all mattress stores are all basically clustered together, or why like like kind of like the vendors are basically all clustered together in the kind of the center of the beach. I'll also find a link and I'll put it to the chat. But Bruce, are you familiar with like they're relatively kind of outliers in the economics fields, but recently a couple of economics professors, Samuel Bowles and Herbert Gintis, they published a book published by the Princeton University Press, A Cooperative Species, Human Reciprocity and Its Evolution.
I've heard of it. I haven't read the papers and stuff, but I've heard of those theories and so forth. So I would be, I'd embarrass myself talking about it because I know so little about it. But I know what you're talking about. That there is this, these theories that are out there and very, very powerful. But that's, but I don't know of them. Well, I know of them, but I don't know what they are and so forth. I haven't studied them.
I get the sense they're still kind of like, the odd guys out, like that really like, most of economic kind of academic activity is more aligned with the status quo, and
like everybody's still going with John Locke and prosperity of nations and stuff like that, where everything is based on greed, where we have an economic system and it's all based on greed on a level playing field. So if you have a level playing field and everybody's greedy, it will greatly enhance humanity. And the problem with that is, well, as soon as half the team wins and the people that actually win on the first go round change the rules, it's no longer a level playing field. So now you have an unlevel playing field, and you end up eventually with the Nash equilibrium, 6 people in the world having all the money, which is where we're at. And then eventually one person will be left in the room with all the money, and that's how zero-sum games end up working. So we definitely need to look at this particular problem, and I think Nash is brilliantly, because what he did was he went back and said, no, it's not the survival of the fittest, it's the survivals of the people who cooperate the most, of the species that cooperate the most, which is amazingly brilliant. And it's so revolutionary that we're still trying to catch up. Sorry, Richard, you had more to say?
No, that's fine. That's fine.
Okay. Okay. Cole, we're going to have to wrap this up, but anyway, give it a shot. And Joshua has a point. Okay, Joshua, we'll let Joshua go first, because if you don't mind, Josh, you had something to say.
Yeah, so something about cooperation, and cooperation as also being a part of competition, because when we talk about cooperation, I think we leave it apart from competition because we think those things are antagonistic, but they have to have some kind of synergy, because even when it comes to education, mathematics, for example, I get and learn the most from the problems that try to trick me the most.
Yeah.
So I need to be challenged and tricked and deceived to some extent. And the professors I've favored the most in my mathematical education are the ones that people kind of don't like and feel like they're the hard asses, or the ones that are trying to dupe you. But it's like a good dupe and a trick that really gets you to think about something. And it's not until maybe I have my concepts violated in a certain sense where I think I know how something's going to go, but lo and behold, this is much more complicated than I could see. And there's this layer of nuance that can only really be brought about by me being confronted with my own foolishness, that I really learned something. And so I hope that in our search for cooperation, we don't throw away this dynamic, that sometimes we do need it to be the case that there is something of an antagonistic bent, even in what is good, because antagonism is something of a force or an agent for understanding or learning.
Oh yeah, I totally agree with that. Like I say, please don't take anything I say to an absolute form. There are exceptions all over the place. and stuff like that. And very much something, sometimes with a cooperation within a society, there are, all sorts of competitions within that society and stuff like that. But everybody on the whole works together and so on. But yeah, I hear you loud and clear over trying to learn mathematics and competing. I always think of mathematics problem as the enemy or some sort of demon that has to be exercised or so forth. This is my approach in order to solve differential equations that are really, really hard. Okay, Cole, I'll let you speak, and you're going to be it. I'm afraid we'll cut her off.
All right. Yeah. I was going to talk about, okay, so Kropotkin has something really good on mutual cooperation, and it's examples in biology and in human society all throughout its evolution. So that's a good one for Richard. And also I was, interested in the that study. You were saying that basically humans acting in their, not in their own self-interest, but in their basically the opposite, creates an equilibrium. What study was that, or was that?
Oh heck, that's my own.
That's yours?
That's mine.
Let me look that up. Do you have to buy
that's
it?
the book I'm trying. Yeah, that's the book I'm
Oh,
trying
it's
to
the book you're selling.
That's my book. That's really, we've come down to that. We've come full circle, because the conclusions I'm coming to is like it comes down to a decision. When push comes to shove, will you do that which is of best to others, even though it may mean to the detriment of you and your loved ones, or will you do that which is best for you and your loved ones, even though it may be to the detriment of others? That you cannot answer that question until push comes to shove.
I'm going to be
It has to come down to the real nitty gritty. And that really is from, what is it? The Giving of the Potato. Man's Quest for Meaning is where that comes from.
Viktor Frankl.
And yeah, that's right. It's a Frankl decision. Yeah.
Yeah.
Frankl. Yeah.
Well, but I'm going to be a stickler. I really want the equations. Are they going to be in there?
Oh, you will have a few mathematical equations. I promise you, you will not be short of mathematical equations. I guarantee you.
Well, you just earned a reader.
Oh, thank you so much.
What was the name of it again?
Physical Truth. You can get it on Amazon.
Gotcha.
Okay, just look up Amazon Bruce Rout and the words Physical Truth, and you'll get it. It's even on Kindle. Okay.
Cool.
Okay, Oded, I'll give you the last shot.
Intuition versus mathematics. I work in aerospace for many years. I don't have any degree except my undergraduate. I have lots of intuition, that's an issue. Then comes the PhD and put the equation. And the question, what is really moved, the intuition or the equation? You are the other side, you put the equation. I put the intuition.
Okay.
It's a human kind of.
Well, you got to have the intuition to get the equations. You have to understand what the equations are and so forth. So they become like a tool in your kit bag. And you may throw the equation out, which may work or it may not. And you try another equation, or we'll have to make one up, which really comes from intuition. And there is something like, I agree with you totally, Oded, that there is an intuition in trying to be able to work this applied mathematics stuff. It's a black art. It's a black art to try and find it.
Not black art, sorry.
I'm sorry?
Green art.
A green art. Yes, it's a green art. I agree with you totally. Okay, Philip, we're back to you, sir. Would you like to wrap this thing up? Thank you all very much. Thank you for lasting to the end. I can't believe it's been an hour, 2.5 hours or whatever it is that we've been at it. Okay, thank you. I'm just so honored. I'm really honored. Thank you.
Thank you, Bruce.
Thank you.
Bye-bye. I'm going to stop recording now.